So today, again, we're going to be talking about augmented reality using React Native. Yeah, we'll look at a particular AR framework called Viro, which will utilizes React Native to create cross-platform AR apps, and we'll answer the same what, why, and how of Viro. So what is AR? So augmented reality is the integration of digital information in a user's environment in real time. So unlike virtual reality, where it creates a totally artificial environment, the augmented reality uses the existing environment and overlays new information on top of it. So put a different way, VR creates a virtual environment that is closed off to the real world, whereas AR places virtual objects in the real world. So here's an example of a VR app. This is from an app that Viro provides, but basically this just shows different sections of the hardware. But you can see I'm kind of looking around, and it seems to be an entirely separate environment from where I would be standing at the time. So AR, on the other hand, may be something like this. And albeit this is a ridiculous example, but you can see like there's kind of characters jumping around. They appear to be existing within that environment. I can put them on certain surfaces and notice how like the ones on the floor appear to be on the floor, and then like there's a dancing ice cream cone man who's on a table. So kind of the difference between the two ideas. So today we're going to be looking just at AR and not necessarily VR. I'd say there's a focus on AR specifically within the past couple of years. And a lot of it has to do with VR not really gaining as much widespread traction as people were anticipating over the years. So there's still a lot of room for improvement, as you saw earlier. But I think the focus on AR, or the VR just hasn't quite hit its peak yet, because mainly it's been focused on a lot of cutting-edge technologies, particularly with gaming. It is, however, making its way into more primary markets. So another thing is that good quality hardware is relatively inaccessible and expensive, things like the Oculus Rift and whatnot. So to get the full VR experience, you kind of have to put some money down into the game. So these two aspects are rapidly changing, absolutely, but it's just not quite at the rate people were expecting it to be maybe 5 to 10 years ago. So AR, on the other hand, is wildly accessible through all sorts of devices, particularly mobile phones. So iOS has ARKit, which is on pretty much all modern devices. Android has AR Core, which is on most every device that's modern and continues to be rolled out to a lot more. There's also a huge popularity with apps such as Pokemon Go, Instagram, Snapchat, where you can put filters on things such as your cat, or see the Pokemon that looks to exist in the real space. So it's a lot more accessible to a wider range of audiences right now. So how does AR work? So generally there are two main aspects to it. The first, there needs to be a tracking engine, and this is basically just something that can understand the world around it and know where it is within relation to its environment. So mobile devices, for example, are excellent tracking devices because they can use the camera as well as all the processors, motion processors, and everything like that to calculate certain things and figure out where a certain environment lives, where it can figure out where surfaces are and things like that. Second, there needs to be a rendering engine. And so even if a device can track the world around it, there still needs to be a way to draw virtual objects within that space. So some things a rendering engine might be responsible for. So 3D rendering, obviously, drawing the objects within the space, maybe doing the lighting and shadows within that space to simulate the sun or other lighting sources. There are physics involved to allow for 3D objects to interact with each other. Things like gravity and friction all come into play here. And then animation, so maybe animating a character's movements throughout a scene. So those are just kind of different things the rendering engine might be responsible for. There are a couple of popular options for a rendering engine. So one of the first things from the iOS side is something called SceneKit. It was built by Apple, and it's what a lot of iOS developers use when they're working with AR. The issue is that it's just not cross-platform, so if you want to build an Android app, you're not necessarily going to be able to use this engine for that same cross-platform application. So there's also Unity or Unreal. I'd say a lot of the focus for that is on gaming. It's a full-fledged gaming engine, extremely powerful. It is cross-platform, but the thing that me as a web and mobile developer that I care about is that it's not necessarily JavaScript-based, which I don't really know. I wouldn't know the first step into how to program within these languages. So, for web and mobile developers looking to build native AR experiences, it's a huge undertaking to learn a whole new language and paradigm of programming. So an ideal solution might be something based on what I already know, like JavaScript or React, which leads us to something called Viro, which is it is cross-platform, iOS and Android, and the biggest benefit, particularly to web and mobile developers, web and React developers, is that it's React-based. So, from that, what is Viro? Viro Media is a company that specializes in AR and VR, and they're the creators of Viro React. Their main mission is to enable developers to build AR experiences, which will ensure a better, larger, and more diverse ecosystem of applications. So the clip we looked at earlier is actually Viro's example app called Figment, which is in both app stores if you want to look for it. They built this app just to show what's possible with their technology and kind of serve as some examples of the things you can do with Viro. So Viro React is a platform for developers to build native cross-platform AR and VR apps. For AR, Viro React supports ARKit and ARCore. For VR, you can also use the Google Cardboard for iOS and Android, as well as the Daydream or Gear VR. So why would you use Viro? First, it allows a lot of companies to focus on what they do best and the languages they know best and are most familiar with, instead of training or hiring specialized 3D developers for AR aspects. It's also very powerful because it uses the latest underlying technology for native development. So when a new native feature is introduced, it'll be available within Viro soon after. And finally, it's readily available for anyone to try out, which makes building AR and VR applications more accessible than ever, especially for web developers. So how does Viro work? The platform is composed of two main components. The first is a high-performance native 3D rendering engine that we mentioned earlier. It's essentially on par with Apple's SceneKit, and behind the scenes, Viro is kind of hooking into the native technology for iOS and Android. So even though we're interacting with this through JavaScript, the actual rendering process is handled natively. We get all the benefits of a native application, but with the added benefit of writing the code in one place and having it run on iOS and Android. The next piece that they provide is a custom set of native components, React Native components for AR and VR to make development as seamless as possible. So we'll be looking at many of these in just a moment. Viro also has a testbed app that you can run during development to make the iteration process even quicker. So you just run the app locally, type in a generated address in the testbed app, and then you can run your app on your device without having to connect it to a computer. So this is extremely helpful, especially when you just want to play around with a few ideas and not necessarily get a whole process going. If you have any native development experience, the iteration process can be kind of slow and time consuming, but this process is much faster. You don't even have to connect your phone to your computer. So now we're going to be looking at a lot of different examples and code samples of what is possible with AR and Viro. So again, we're going to have lots of code ahead. Not live coding, not that brave, but there's going to be examples that will give you a more fine-tuned look at what's possible and what's possible with Viro. So with that, let's jump into it. So at the root of every AR scene is the AR Scene Navigator. It's the entry point to an AR experience. There's also a VR Scene Navigator for VR. It just needs an API key, which you can get for free from Viro, as well as the initial scene that you want to render. So like I mentioned before, Viro utilizes React Native and thus React, and so you'll be using JSX with their components. So within this render AR scene that I'm using, you would have something like this, where we have a AR scene as the main wrapping component for each scene. It has various properties and callbacks so that to further enable interaction with the scene. The one I'm using here is OnTracking Updated, which will essentially be called initially when the device can successfully detect a space. So, and any updates that happen further will get called here, such as like a loss in tracking, for instance. So this is typically used to make sure that a device can fully understand the world around it before you actually want to render something. So you might have kind of a loading state before you actually render a 3D object onto the screen. So let's look at the onInitialized method we're passing this. So I'm essentially just checking to make sure that the state that we get from the OnTracking Updated method, I'm making sure that it is tracking, and then I'm just simply setting a state value so that I can know when it's safe to render something. So otherwise, the user would likely see some objects jump around before it finally settles into one place. So like I mentioned before, we're using React and React Native, so we still have access to a lot of the common patterns of React, such as state, to help us with our AR rendering and logic. We can use that state tracking value to conditionally render some text. So Viro text is just a basic text component. We can see that it just accepts a text property for what should be shown, as well as a few more. One thing to note is, coming from a typical web and mobile development, we're used to positioning things within an X and Y axis. However, AR and VR bring a new dimension that things can occupy. So now we have to account for a Z-axis, which is forward and backwards. So kind of a visual representation of that. You can see that the X and Y, based from the camera's perspective, the X and Y axis still go left and right, up and down, but then there is a Z-axis that's going forwards and backwards, and the camera is pointed in the negative Z direction. So that's helpful later on when we get to positioning things within the space. So back to the code. By default, the device, the camera device, is positioned at the origin 0, 0, 0, which represents the X, Y, and Z values. So the device will initially point in the negative Z direction, like I said. So in order to make the text appear in front of the device, its position needs to be 0, 0, negative 1, meaning a negative 1 Z value, which means it's 1 meter, 1 full meter in front of the device. So at the bottom, you can also see that there's a style prop, which if you've worked with React at all, or React Native at all, it should be very similar. So the style that we're giving it is essentially the same thing that you would do for React Native or just CSS with React. And now, so here's an example. Here's what it looks like. The text I rendered was 1 meter in front of the camera when the scene got kicked off, and then however it stays in that position, I can go and look around it, and the text is going to stay in that position. One thing to mention here is that all the examples we'll be showing, except for one that's later, they're all going to be cross-platform, like the title of the talk says. So this would be the exact same experience on iOS or Android. So next up, we're going to talk about various 3D shapes. So Viro has a lot of different options for like a base shape that you can work with. So here's just a box example. So it just has a height, length, and width, as well as a material that we'll look at in just a second. So we have a box, kinda. So the box is there, but it's tough to perceive its size and depth because there's no shadows or shading, and there's no lighting source. So we need some sort of lighting source to shine on this box so that it can appear to be more of a part of the environment. So in order to fix that, the first thing we actually need to do is create a material, which this is going to be wrapped around the box. Okay, and this material is actually going to be the thing that receives the light from our light source that we'll look at in a second. So we use a method called create materials. We're creating a material called white. You know, the lighting model, there's a couple of different options that you can choose from that just affect how that just determine how light affects it. So some are more shiny, some are more matte, but those are the different lighting models that Viro provides, as well as just a color that we want it to be. So I'm just passing it a RGB color. It could be a hex color or anything like that. So along with this material, we need a lighting source. So Viro provides a number of lighting options as well. So here we're using an ambient light at the top, which just kind of gives some general lighting to the whole scene. And then we have a directional light, which, as the name implies, it's a directional light that, much like the sun, so it's going to be shining from one point in a certain direction. So we can give it some coordinates of where we want to point. And we can also say that it should cast a shadow. So there's certain things like that. And now, just dropping those into the scene, this box now can receive light, or receive the light and shadows, so it has a little bit more depth and presence. I can walk around it, see it from different angles, and the shadows and shading seem appropriate for what's there. So, like I mentioned earlier, Viro has a lot of different standard shapes that are available. So we could switch this out for a sphere, which only needs a radius to determine the size. So simply just dropping that in, now we have a sphere. So you can see the lighting is coming from one direction. I have it positioned kind of up into the side, so you can see it's affecting half of the sphere. So we have a light side and a dark side of the moon. So we can also wrap this sphere. We're wrapping it in a color right now, but we can also wrap it in an image. So I downloaded an image of the moon and created a new material called moon. The only difference is that we're using a diffuse texture, and we're just simply requiring that image from a JPEG file. So that file looks like this. So you can see that around the top and bottom, it appears to be stretched out. That is to account for like the smaller radius that's at the top and bottom, whereas in the middle, it's nice and open. So this entire image is going to wrap around the sphere. And now there's a moon that's floating in the space. The lighting still affects it, and everything like that. So yeah, there's the dark side of the moon. So the next thing we can do to build upon this, I think it'd be pretty cool if I could like drag around and like touch my finger on the screen, move this moon around in the space. So let's see how that would work. So most Viro components have an OnDrag property precisely for that reason. Here I'm just using it to set state. There's an X, Y, and Z value in state, and I'm just using its position to set that, and then the position for the sphere itself, instead of doing 0, 0, -1, we're going to use the state value that we're setting when we drag it. Okay, so again, we're manipulating this in mostly the same way that you might do something in React or React Native, using state to keep up with the state of the AR scene. And now I can drag this around. You can't really tell as much, but that kind of gives you an idea. I'm literally on my phone, moving my finger around, and you can see that it ends up in an entirely new place from where it started. So lastly, since this is the moon, after all, it'd be cool if it was spinning in place. So let's try working on some animations. So in order to create an animation, there's a method that Viro provides called register animations, and I'm just creating an animation called spin, which it's just going to rotate the moon around the y-axis. The plus equals that's on there means it's going to add 45 degrees, and it's also going to happen every 2 seconds based on the duration. So probably not astronomically correct or anything like that, but it'll do fine for now. And then we can use that animation in the animation property of the sphere. So we just need the name of the animation we want to run, and then a run value, which determines when it should start. And in this case, we want it to start immediately, so we're just setting it to true. And then we're saying that it should be a looping animation, so that means we want it to continuously run indefinitely for the entire length of this scene. And now the moon will just be spinning in place. It still could be moved around if I dragged it, but it would still be spinning at that constant rate. So the shapes are pretty cool. There's a lot more shapes that you can get into, and you can build a lot of really cool things. But if you've played Pokemon Go or anything that's remotely advanced, you'll notice that they're typically more complex and just detailed objects that you work with and that you interact with within the scene. So luckily Viro has a component called Viro 3D object, and you can use pretty much any 3D object really easily. So if you don't know anyone who builds 3D objects or things like that, there's a number of online resources for free. So there's something like Turbo Squid, which you can download a whole bunch of things for free. And there's also a lot of great paid options as well. There's Unity Asset Store, which is a great resource to buy some things. So there's an example I'm using today. It came from one of these sites. So I downloaded a dinosaur that I want to put into this scene. So I simply add the file as the source, have the position in front of me, and then there's a scale because dinosaur is relatively large, as it should be, so I want a smaller version of that, so I'm scaling that down to 0.1, 0.1, 0.1, which is going to make it a lot more manageable, and it'll fit into the scene. And yeah, so now we have a giant dinosaur, or medium-sized dinosaur, that's in this office that I'm in. So it's cool. It's cool. There's a lot of detail. You can see a lot of aspects of what's going on, but it's just kind of floating in space right now. So ideally, it'd be really great if it was if it could sit on the floor somehow, or kind of look like it's a part of the environment. So to do this with Viro, it's actually extremely succinct and short to do that. But just to give you a quick overview of what something like that might look like with, if you were to do this natively. The example I'm going to show is in Java, but it'd be a very similar process in Objective-C or Swift or something like that. So you don't necessarily have to follow everything going on here, but just to give you an idea, first we're going to create the scene. We're going to set a listener, and it's going to listen for when a anchor is detected, which is basically just anything that it can detect. And then we make sure that the anchor is a plane, and then we make sure it's a horizontal plane of a certain size and make sure it's large enough. And then we create a 3D object. We load the actual 3D object onto the object we created, and then we add the child node to the scene that was detected. So just lots of steps involved, whereas, again, the Viro way is a lot more succinct. So it's extremely compact, and it's also a lot more declarative, I feel like, of what's going on. So we wrap whatever we want to render in an AR plane selector. And essentially, whenever there's a plane detected, it will automatically render the component's children onto the surface. So here's kind of the plane selector working on its own. This is in like a debug mode, just to give you an idea of what's going on. And so you can see there's like a visual indication of there's the floor. It also detects this upper space up here that you can see that it knows that that's a surface that something could be rendered on. So now I am rendering the dinosaur on the floor, and you can see that it's smart enough to know where that is and how to render that on that plane. So again, this is pretty cool. Again, but there's something missing. Essentially, it'd be great if there was like a shadow or some kind of way to, again, make it even seem like more part of the environment. So to get a shadow, we're going to need a lighting source again. So I'm going to use a spotlight here in this case. So I'm going to put that on top of the object, and then we're going to use something called a quad to render a surface for the actual shadow to be rendered on. So that's kind of the important thing here is that if we were to just cast a shadow, there's nowhere for the shadow to actually be rendered. So we have to create this quad, which is essentially just a flat 2D surface of a specific height and width. And you can see that it also has a property like shadow receiver. So we want that to be true so that it can receive a shadow from the lighting source. So now this dinosaur has a shadow that's being rendered on that quad, and it's coming from that lighting source. So lastly, for whatever reason, I think it'd be cool to interact with this dinosaur. So maybe I'm going to touch it, and then it's going to start moving at me or what have you. So it's going to receive some sort of event to trigger some sort of animation. So first thing that we can add is there is an OnClick method for most all the components that Viro React provides. And then, so we're just setting a state value of run animation. And then with that value, we're then using it in the run value for the animation. So whenever we click it, it's going to set animation run to true, and then we're going to run a particular animation. So you can see we're using an animation called move. So let's take a look at what that looks like. So it's just move. We're changing its position Z. We're adding 0.2 meters, and that's going to happen every single second here. So this animation is not that interesting, unfortunately. But so say that there was a very custom animation that the creator of this dinosaur created that moved around, did all sorts of things. We could trigger it in essentially the exact same way that we're doing here with this custom animation. So now I'm looking at it, I can touch it, and then it starts moving. So we could do a lot more with those animations, but that's just giving you a very basic example of how the animation moves. Cool. So next we're talking about something called portals. So it's one of the more popular things that people are doing with AR. You might have seen some viral videos when ARKit came out for iOS. It essentially creates a portal into another world where a user can interact with it, walk through it, and kind of be in an entirely new environment, and then walk back out to their current place. So this is the example that I saw when ARKit came out. So you have this doorway that there appears to be a world on the other side, and so as you walk through it, you can see that you're just in an entirely new environment, and look around, and also you can well, we didn't get back to the walking out of it, but yeah, you can walk out through the doorway just as you came in. So as you might imagine, building this kind of feature natively would be pretty intensive and just have a lot of things moving and a lot of moving pieces to it. But the API that Viro built for this particular aspect is extremely simple. So at the root level, we have a portal scene. And this sets up the scene that's going to be rendered inside the portal. So anything that we want to render inside of that is going to be inside that portal. So here we're using a 360 image that's going to be inside the portal once we walk through it. So the only requirement with this portal scene is that it needs a portal to walk through, which is, again, that creates the doorway. And then the actual shape of the doorway we're walking through is going to be a 3D object that this one just has a ship's window that we can look through, we can walk through it, and that's going to be the entrance into this entire portal of the scene that we're going to look at. So let's take a look at what that looks like. So I have this ship's window. See, there's nothing behind it, and then I'll walk into this scene, and now this is a 360 image that I just loaded with that 360 image component from Viro. Again, I can walk back through it, and that doorway still stays at the same place. I can look around the entire scene. So this is actually, I took this with a 360 camera in Joshua Tree National Park, in California. So yeah, just a 360 camera on my own. We can also use a 360 video. So simply just by changing out that component for a 360 video component, I upload a video that's a 360 video as the source, and then now we have something like this. So this is from a ski trip we took, but see, it's a video that's I can look around, the video's playing, and then I'm still able to kind of walk around and go back through the portal. So in these examples, we're just using like a 360 images and videos, but as the first example that we looked at, it had a lot more details of what's going on. So what's inside that portal could be a lot more advanced than what we're showing here. So AR experiences, I feel like they could be enhanced by using known features of a user environment to trigger the appearance of virtual content. So for example, our company, we just got these really cool Airship Coffee Mugs, and I thought it'd be a really cool idea if maybe someone points their phone at this coffee mug, at this image, our logo that's on the mug, and then that'll trigger some sort of text and animation when it recognizes that particular image. So let's take a look at what that is going to look like. So Viro provides an AR image marker, and that's kind of what you're going to wrap what you want to happen, what you want to have rendered once it detects a certain image. So it has a target, which we'll look at in just a minute. So the target is just Airship logo. And then when the anchor is found, I'm going to run an animation. And this will kick off some animation that we're going to look at for the objects that are rendered inside of this AR image marker in a second. So to create that target, the image that we're looking at, Viro provides a create target method, and we're just calling it Airship logo. I literally just uploaded the PNG file of our logo, and then we also kind of give it the physical width of the general size of what it's looking for, as well as the orientation, so it's going to be pointed up, not flat on the ground. And then we're also going to have two animations that are going to run. So like I said, I want some text to jump up from the bottom and then also rotate in place. So we have two things going on. So the first one is slide up, which that's just going to animate the position, the Z position, as well as the opacity, and that's going to last 70 milliseconds. But we also have this rotate property that's going to rotate around the Z axis, and that's just going to happen indefinitely. So to use those two animations, a particular object can only accept one animation, but we can do something like this, where we have a node, a Viro node, which is essentially just an empty 3D object that can contain certain properties, and it can also be animated. So that's going to accept the slide up animation, which we just want to have happen once. And then we have the text, which is like we looked at earlier, and we want that to be spinning. So when it detects the image, the node and the text are going to slide up, and then the text is also going to be rotating in place. So altogether, the relevant code looks something like this. I know it's small. You don't necessarily have to follow what's going on. We just looked at every aspect of it. But at the top, we have the image marker, and then inside of that, we have the node and the text that are going to be rendered. And then right there in the middle, we're creating the target, which is just the image to detect. And then at the bottom, we are creating the animations that we want to run. So now here it is in action. So it detects that image, kicks off that animation, as well as the both animations, and now that's just spinning in place. So notice that it's there in relation to the image that it detected. So if I were to move that mug around or hold it up in the air, that object would still stick with it as it's moving. So along the same lines of image recognition, we can use the exact same technology to recreate one of the classic examples from the world of Harry Potter. And so if you aren't familiar with Harry Potter, a lot of the pictures, they act as videos. So if there's an image printed out in the newspaper, it might be moving and talking. So here's what that might look like. So using essentially the exact same thing that we just did, we can recreate this. So So here's an example. I printed out an image, which we'll look at how we're going to make that come to life in a second. So I printed this out. That's going to be the target for the AR image marker. And then we're just going to render a video on top of that image so that when it detects this image, it's going to immediately render that video and start playing. And so this picture is actually the first frame of like a Charlie Chaplin video that I found on YouTube. So again, when it renders that video, it's going to look like that image started playing. So again, I've created the target, and I'm just adding this video right here. I'm also giving it a specific height and width to make sure that it is the same size of the image that was printed out. So again, when the app detects the target, it's going to render the video at a specific height and width and rotation, and it's going to look like the image just started playing. So here is that example. So now that image that was printed out just looks like it's a video now. I can move that around, and that's going to stay static to where that image is detected. So I can see this being in magazines and things like that. I mean, it's a realistic option to have those images come to life in more traditional ways. You might have also seen like this kind of technology with a wine company called 19 Crimes. It might be an American thing, but they created this app that goes along with their wine, and you point it, and the wine starts talking. So you can see how easily this would be to duplicate this exact application with the code that we just looked at right there. So image recognition provides a lot of opportunities for interaction, but it'd actually be really cool if we could detect objects. So I'm talking like a physical object. So luckily with like the release of ARKit 2 last summer, Apple made that technology a lot more accessible. So one of the things to note, this feature specifically is not available on Android. It's specific to iOS at this point. It's kind of it's a limitation of ARCore and not necessarily Viro right now. So Viro has an AR object marker. It behaves in almost the exact same way as the image marker, except the only difference is the source. So if you look at the file, it's a .ar object file. And so this particular type of file is something that Apple created. And Apple actually has an app that you can download to create these AR object files. This is Apple's app. It essentially creates a file with a bunch of nodes in 3D space. So it's scanning this remote, not this one, but one at my house, and it's scanning the remote and making that a unique file that has a bunch of nodes that match that remote specifically. So in the example that we're going to be building, it's attempting like a common household problem of you have too many remotes that you can't remember what they do. So again, we have that remote that we just looked at. I also scanned another remote, very similar to this one, that it looks almost identical, but there are certain small things that are different. And so I've scanned both of them, and we're going to have the app detect which one is which. So again, I have those two targets that I've already created. I just put them into an array with some text that I want to render, and then I'm just mapping through that array, and then that's going to create the object marker for each one, as well as the text that needs to be rendered. Yeah, so let's see how that works. That's literally all the code that's needed. And now I'm going to point at the first one. It's going to say that's the DVD remote, and that's the TV remote. And so that's just from those two AR object files that are there. So the technology behind the scenes with ARKit is able to match that AR, scan things and match that AR object file and compare it. So the last example we're going to look at is to show how an AR experience can also coexist with your existing React Native components. So the app we're going to be building is going to be a minimal take on something called a money grab machine, where you're in a small booth filled with money and you try to catch it. So these might not be very common over here in Italy, but this is a standard household thing in America. So if you aren't familiar, this is what it looks like. Yeah, so let's check out the code and see what it looks like. So at the root level, we have everything wrapped in a view. And the view is from React Native. Then we have the AR Scene Navigator, which are going to render the AR scene. And then we're also having some text and a button to restart the score. So again, both of those, the text is using just the text from React Native. It also has a touchable opacity from React Native. So you can see that we have a scene that's being rendered. The video is being rendered from the AR scene. And we also have the text and at the top with the score and the restart button at the bottom. That's coming from React Native. So these can kind of seamlessly coexist. So in order to actually create the dollar bills onto the scene, first I'm just going to keep an array in state of dollar bills, and then I'm going to randomly create a dollar bill with a position and a rotation that's a randomly generated number, and that particular function is just going to be put into a set interval that's just going to be called every single second. And so there's going to be accumulating all around me, and there's just going to be a lot of dollar bills accumulating over time. So again, we're able to map over that item and state and just create a box. And we're using that random position and rotation that was generated, and then we're just giving it a height and width, and then we have a material, which is just a dollar bill that we're wrapping it in. And yeah, and then OnClick, I have a method called onDollarSelected, which is just going to remove it from state, which then removes, it's going to bump up the score by 1 in state, and also just remove it from the screen. So now, here's that example. Again, very basic example. Didn't go into all the crazy animations of flying around, but you get the idea. So there's like random dollar bills that are just placed all around me. I can touch them, and the score is going to be bumped up by 1. I can click the restart button, and that's going to reset the score. And all that's using React Native logic to handle all that state. So there's still many more components other than what we looked at today that Viro has available. They can account for pretty much anything that you can think of when it comes to AR and VR. So as you can see from the code examples, a lot of this looks very familiar if you've worked with React or React Native before. So 3D space, I found, it does create some additional perspectives that require a slightly different way of thinking, but to be able to walk into an entirely new paradigm of applications and already kind of have a good base understanding of what's going on, I felt like it was a very big win for efficiency. So I personally found that learning AR has been extremely exciting, and all indications point to the AR continuing to grow and evolve over time. So all the demos that we showed today are on my GitHub. You'll just need a Viro API key to start running the examples. You might have to do some stuff with Android, but other than that, all that should be working. So again, that's my talk. Thanks for having me. This has been fun.